Hi everyone, Miss Barber here on lesson 1.5 of Algebra 2, Properties of Exponents. So this should be a review of Algebra 1, but I know for many of you Algebra 1 was a long time ago. So these are the basic properties of exponents and we're going to be applying them here. So in general, we have this kind of general format here where the base is always the big number, the exponent's the little number up in the right hand corner, and that tells you how many times you are multiplying the base. So in this case our base is b, our exponent is a, so we are taking b and we are multiplying b by itself 8 times. So that's a basic exponent of repeated multiplication. When the base includes more than one symbol, it's written in parentheses. So you'll see here we have negative 2x to the third. We're multiplying only the x 3 times. So in expanded form, you'll see that the x is written 3 times. In my second one, 2x is in parentheses, so we're multiplying 2x 3 times. The negative stays out in front. In the third example, negative 2x is in parentheses, so I'm multiplying negative 2x 3 times. When you have negatives in there, that will make a difference how many times you're multiplying it together, so be careful about that. So example 1, write each expression in expanded form. So number 1 here, our x is the base that's being expanded, multiplied 5 times. So I have a negative 3 out in front. That's not being raised to the 5th power, only the x's, so you have to include 5 x's there. In number 2, j minus 3k is the base. It's in parentheses and it's being multiplied out 3 times. So you're going to write j minus 3k 3 times. Now, in number 3, think about it. What is being raised to the 4th power? Only the thing in parentheses is. So pause the video, try number 3, expand out what's in parentheses, and check your answer against the key. Now we have 0 and negative exponents. The 0 exponent property says anything that you raise to the 0 power is going to equal 1. So no matter what number, other than 0, you can't have a base of 0, but anything else, when you raise it to the 0 power, it will give you the answer of 1. So we're going to be substituting 1 in for things raised to the 0 power often. The negative exponent property says when you have something that's a negative exponent, you have to flip the fraction. That's that word reciprocal. We've seen that before. You have to take the reciprocal of what's ever in parentheses or whatever is being raised and flip it and change the exponent to a positive. So whenever you see a negative exponent, you should be thinking about flipping the fraction. So number 4, evaluating each expression. I see a negative exponent. So with my negative exponent, I'm going to take what's in parentheses and flip the fraction. So instead, it's going to be negative 1 on top, because this is like negative 2 over 1. So it's going to be negative 1 on top, and then negative 2, which was in my parentheses, is going to go now to the bottom of my fraction. So I flipped my fraction, and I'm going to put a positive 4 now as my exponent. Well, now it's just a matter of finding out what negative 2 parentheses raised to the 4th power is. That's like negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. So your final answer is going to be negative 1 over positive 16. For number 5, my whole fraction 5/8 is being raised to the negative 2 power. So again, I have to flip my fraction, make it 8 over 5 to the positive 2nd power. So I did the reciprocal. Now we have to, and this is going to come up in a minute, we're going to have to distribute this exponent to both the top and the bottom part of my fraction. So it's going to be 8 to the 2nd power over 5 to the 2nd power. 8 times 8 is 64. 5 times 5 is 25. So that is your answer for number 5. Pause the video and try number 6 on your own. Now we have more properties of exponents. So pretending a and b are real numbers and integers are m and n. So my exponents, m and m, they're only going to be positive or negative numbers with no decimals or fractions. Makes it easy. We're only going to have basically whole number negative exponents. The product of powers property says when you multiply two numbers together that are the same base, so notice we both have 4 here, or a and a, when they have the same base, you're going to add the exponents. So 3 and 2, you're going to add them, or m and n, you're going to add them. So when you're multiplying bases that are the same, you add the exponents. So add the exponents. So the inverse of multiplying is dividing. So now when you're dividing powers with the same base, you're going to subtract the exponents. So instead of adding 7 and 2 here, you would be subtracting. So subtract the bottom from the top. A power of a power property. So when you're raising a exponent to another exponent, you're going to multiply. So m times m, you're going to multiply your exponents when you raise a power to a power. So when you see those parentheses like that. You can also distribute your exponent to if it has multiple things in parentheses. So here 2 could be distributed to the base of 3 and the base of 4. So m can be distributed to a and to b to give a to the m, b to the m. And same thing with a fraction. We saw this when we did number 5 above. You can distribute the 2 inside of your fraction. Or you can distribute it to the m like we do here. So those are the properties that we are now going to apply when simplifying exponents. So you're going to have to use your properties to simplify expressions. You're not going to want your final answer to have any grouping symbols, so no parentheses. You're going to rewrite all negative exponents as positive exponents. So all of your answers should be positive exponents, not necessarily positive bases, but positive exponents when you're finished. And just like all things in algebra, you have to combine like terms. So example 3, let's simplify each expression. Before I do anything, I see I have a 68 over 4. Well, I know I can simplify that following my basic fraction rules. And this will be simplified to 17 over 1. 68 divided by 4 is 17. You don't have to write the 1, but know that there is a 1 there. I see I have lots of negative exponents. Remember, when you have a negative exponent, it moves either from the top to the bottom or the bottom to the top of a fraction. So I'm going to move g to the negative third to the bottom of my fraction, and I'm going to move f to the negative third to the top of my fraction. So simplifying this, I'm going to have 17, f to the fifth that was already there, and now my f to the negative third is going to be f to the positive third on top. My bottom, I have the 1. I'm not going to write it this time. I have my g to the sixth that's already there, and now g to the positive third that moved down from the top. So now all of my exponents are positive. I don't have any parentheses. Now it's just a matter of combining like terms. Well, I have f to the fifth and f to the third here both on top. We're multiplying the two bases together so I could add the exponents. So I have 17 f to the 5 plus 3. In my denominator, I have g to the sixth and g to the third. Well, those are the same base, so I can combine them by adding the exponents. So I'm going to get g to the 6 plus 3. So my final answer is going to be 17 f to the 8th, g to the 9th. Now I have no variables that show up more than once. I have f all combined, my g all combined. Everything is positive with my exponents 8 and 9, and I have no parentheses. So now I know I'm done. Number 8. So let's try number 8. Number 8 starts with the whole thing in parentheses and a negative 2 exponent. So right away I know I need to flip my fraction. Well, this fraction is over 1. Anything that's not written as a fraction could be written over 1. So I'm going to rewrite this as 1 over. I'm going to keep my parentheses right now because I haven't distributed that 2 yet. But I do now have a positive 2 exponent. Next step is to distribute this 2 to everything inside my parentheses. So I'm going to get 1 over, again, negative 4. It is a negative 4, so you should keep that in parentheses. I'll talk about that in a second. To the second power. A to the 3, remember when you're raising a power to a power, you multiply. So it's going to be 3 times 2, and b to the 7 times 2. So that is going to finally simplify to, when I'm finished, 1 over. The reason it was important to put negative 4 in parentheses is negative 4 times negative 4 is positive 16. If you left that negative out of the parentheses, you might be tempted to write a negative 16 here. But it's not. You're multiplying a negative times a negative, which is a positive. A to the 3 times 2 is 6. And then b to the 7 times 2 is 14. So that is your final answer. Now, number 9, I'm going to get you started on it, and then you're going to finish it up. So it looks really complicated, but let's break it down. I see a negative 2 exponent. Remember, you can't have a negative exponent. So if I write this like over 1, I know everything that's raised to the negative 2, which is this whole thing in parentheses, is going to have to go in my denominator. So I can start by simplifying and say it's going to be 6m to the 4th, 9 to the n to the 9th, all over, I'm going to keep this in parentheses just like before, negative 3 m squared n to the 3rd, now to the positive 2. Well, now I have parentheses, so I'm going to need to distribute that 2 to everything inside, just like we did the last problem. And then once you're done with that, you're going to have more simplification. So pause this video and try this problem out. It's really important that we figure out how to do this without my constant guidance. So try it, look on the key to see if you got it correct, and you can see the work that I did to get to my answer. I do want to mention that you might not always go in the exact same order. There is a few things you could maybe potentially change. So if you maybe did one step different than I did, but you got to the final answer that was the same, you most likely did it in a correct manner, and that should be fine. Now, number 10. The A1 Moving and Storage Company sells crates that measure x squared y units wide and x units long and y squared units tall. Find the volume. So you may or may not remember from geometry that volume is length times width times height. So it's just a matter of multiplying all these things together. So it's going to be x squared times x squared y times x times y squared. Nothing is being raised to any exponents, so now it's just a matter of combining like terms. X squared and x. X doesn't have an exponent, but we know x to have an exponent of 1. We usually just don't write it. So I'm going to have x squared plus 1 for my x's. And likewise for my y's, I have y and y squared. This is like y to the second power. Y to the first power. And then y to the second power, so 1 plus 2. So my final answer is going to be x to the third, y to the third units. And it's volume, so it's going to be units cubed. And that's your final answer. Last thing related to exponents, and that's scientific notation. You use scientific notation to write either really, really, really big numbers. Think about when you're talking about space, stars, how far away the moon is, or really, really small numbers. So you use scientific notation a lot in biology and chemistry class. You write really large or small numbers by using powers of 10. So the typical format for scientific notation will always be a number and then a period. And if there's other numbers, then you would write the other numbers after. If there's not, there doesn't have to be. Times 10 to the, and it's either going to be a negative or a positive exponent up here. Positive exponents mean that the number's big. Negative exponents means your number is small. They're going to be less than 0. So the exponent, so in this case 7 in the first example, means you're going to move the decimal 7 to the right, giving you this 12,750,000 number. In my second example, I'm moving negative 7, so 7 to the left. So you're getting a really, really small number. It's still a positive number, but a number very small and very close to 0. So for writing these answers in scientific notation, just like you might guess, you're going to multiply the numbers out in front, and then you're going to add the exponents of your powers of 10. So you're going to multiply 7.2 with 4.5. 7.2 times 4.5 is going to give you 32.4. And it's going to be times 10 to the, and again, you're going to add your exponents. So I have negative 5 and positive 3. Well, negative 5 plus 3 is going to give me negative 2. So I'm going to have 32.4 times 10 to the negative 2. Now, as I said above, scientific notation is always in the format of one number and then the decimal. Here we have two numbers in a decimal. So we're going to need to move this decimal here between the 2 and the 4. We're going to need to move it 1 to the left to get 3.24. Because I moved it 1 to the left, I can subtract my negative 2 is now just going to become a negative 1. Because I already moved it 1 to the left from this negative 2, so I don't need to move it anymore. So now I only have to move it 1 to get back to your original answer or what you're looking for. So because I moved it left, I have to add 1 to my exponent to get negative 1. So what's in red is my final answer. So for number 12, in 11, we multiplied my two numbers out in front. Now I'm going to divide my two numbers out in front. So I'm going to divide 1.7 and 3.4. When I do that, I get 0.5. And now instead of adding my exponents together, because I'm dividing, I'm going to subtract. So I'm going to do 5 minus 9. Well, 5 minus 9 is going to give me negative 4. So my answer is 0.5 times 10 to the negative 4th. But again, that's not correct scientific notation. You have to have your first number to be non-zero. So I have to move my decimal 1 to the right. So I get 5.0 times 10 to the, because I moved it 1 to the right, I'm actually getting more negative. I have to subtract 1 from my exponent because now that's 1 more I'm going to have to go left later on. So I'm going to get negative 5 for my exponent. All right, so to sum that all up, in number 11, I had to go 1 more to the left, so I added 1 to get to my final answer. So when you're moving your exponent to the left to get your final format, you would have to add 1. To move it right, like we did in number 12, you would have to subtract 1 from your exponent to get your final answer. So try number 13 on your own, and again, check it against the key. All right. Number 14, the average lifespan for an adult living today is about 82 years. Some scientists believe the people born in the early part of the century may live for up to 150 years. Calculate the number of minutes an 82-year-old and a 150-year-old could live. Round your answer to the nearest million, and then record the difference in scientific notation. So first, let's start with the 82-year-old. So if you live for 82 years, and we want to know how many minutes that is. Well, there's 365 days a year. Yes, there's leap years, but we'll just go with 365. And every day, there are 24 hours in each day. And in those 24 hours, there are 60 minutes. So when you do this, you get approximately 43 million. we're just rounding to the nearest millionth. So 43 million works. You're going to do this exact same math with 150. So 150 times, again, 365 days, 24 hours in each day, 60 minutes in every hour. You're going to get approximately 79 million. Well, if we wanted to see the difference, so they wanted us to record the difference in scientific notation. So subtracting 79 million minus 43 million, so doing 79 mil minus 43 mil, that's going to give you 36 million. So to write this in scientific notation, remember you want to put one number out in front, so it's going to be 3.6 times 10 to the, well, if my decimal is in between the 3 and the 6, I would count 1, 2, 3, 4, 5, 6, 7. So it's going to be 3.6 times 10 to the 7th. That's the difference in how many minutes a 82-year-old versus a 150-year-old would live, which is actually pretty incredible if you think about it. Number 15, last one. A movie made 6.7 million times 10 to the 7th. It took 250 hours to film it. How much money was earned for each hour? So this is going to be a division because we want to know per hour how much was 6.7 times 10 to the 7th for each 250. Well, if we wanted to write the bottom into scientific notation to make it potentially easier to multiply or divide, I could write 250 as 2.5 times 10 to the 2. Now I can divide 6.7 by 2.5. When I do that, I'm going to get 2.68. That's already in correct scientific notation, so I'm good there. And then for my exponents, remember we're dividing. When you divide your exponents, you subtract. So it's going to be 7 minus 2, which is 5. So your answer is 2.68 times 10 to the 5th dollars per hour. All right. That's it for properties of exponents. I know this was a lot, but we're going to be practicing this and using this all the time. So hopefully it'll become pretty natural to you as the weeks and months go on. Have a great day.